Okay, welcome to the Intro to Memory video. This is the first video for Unit 5, which is Cognitive Psychology. This is a giant unit. We have a few different sections of the unit. Really, we're going to be splitting this into 4 different sections: memory, thinking, language, and intelligence. So memory is going to be kind of all encompassed of encoding, storage, and retrieval of memory, as well as forgetting and the reliability of memory. And then we're going to look at different thinking processes. And then finally, we'll be looking at language and intelligence. But today we're going to start with memory. And memory is really the way that we show that we have learned something. Memory is our ability to store information that we have learned, but then also to retrieve it and use it again after we have learned that information. So memory is super important to our lives. If we didn't have memory, we would lose the ability to really function in a normal society. And there's 3 different parts of memory. Memory follows in a sequential process, and those 3 parts that we talk about when we're talking about memory are the encoding of memory, the storage of memory, and the retrieval of memory. And all of those pieces of memory are important, and different problems can occur at each stage of the process. And that really will determine how well the memory is used. So let's start by talking about these different stages and what they mean. So the first one is encoding. Encoding is the actual process of creating a memory. I like to use the analogy of a computer. So when you are actually creating a new document in a computer, that is encoding, right? You are typing something into Microsoft Word, you are creating a document, and that is the encoding process. The way in which we actually are creating a new memory. This is when you are experiencing something new for the first time and you are creating that memory. The next step is the storage process. Storage is when we are going to be actually saving that memory, taking that memory from our conscious awareness and moving it into storage. Storage is complex in our brain. We store our memories in different parts of our brain, and our memories are disjointed and taken apart and stored in all different parts of the brain and different structures. But our storage process is the actual saving of information. If we're looking at our computer analogy, that's going to be like saving it to your documents, or saving it to the computer, or saving it to a jump drive, or your OneDrive, whatever it is, wherever you are storing it. That is the storage of our memory. And then finally, this last step of memory is the retrieval process. So when we are pulling that document back out of our drive and we are looking at it again to use for future reference, that is our retrieval. So in memory, this would be taking information from the past, bringing it to our current consciousness to use in that moment. Like I said, each of these processes has their own issues and difficulties, and we're going to talk about each of those more in depth as we go throughout the unit. But that's just an overview of different parts of our memory. The next thing that we're going to talk about is our models of memory, basically how memory happens, how we store memories, how they work. And the major theory of this was proposed by Atkinson and Shiffrin. And in here, it's called the 3-stage processing model of memory. But for IB and for our sake, we are going to call it the multi-store model. And they propose a 3-stage model of memory, which is sensory memory, short-term memory, and long-term memory. We're going to go into these each a little bit more in depth, but I wanted to at least give an overview of kind of how this looks, what the process of information coming in is. So first of all, we have external events that are happening. These are things that are happening outside of our body. They're around us, and those come to us via sensory information. Things that we talked about in Unit 3, right? So visual information coming into our body, auditory information, tactile information. If we pay attention to that sensory information, then it goes into our short-term memory, also called our working memory, which we're going to talk about in a little bit. If we are rehearsing the information that is in our short-term memory, then it gets put into our long-term memory. And this is done through the process of encoding, when we are actually storing the new information. And again, we're going to talk about each of these more specifically in just a second. But once it's in our long-term memory, the information is stored. As I said before, that information is broken up into different pieces depending on the type of information it is. Once it's in our long-term memory and we need to bring that memory back to our consciousness to be able to use again, we retrieve it and the process kind of starts all over again. We encode it again and then retrieve it again. And that's why sometimes memory is distorted. So let's talk about each of these different stages more in depth, and starting with our sensory memory. So sensory memory, like I said, is our initial stage of storage. You can test the sensory memory by closing your eyes. And if you can see outlines of things, that's your sensory memory working. It only lasts for a moment or two. This is like a half a second to 3 seconds max. And really what our sensory memory is doing is it's allowing us to take in information that is important for the moment. So sometimes you're paying attention to things, sometimes you're not. And if you're not paying attention, then we don't worry about it. That information is displaced. And we don't put it into our long-term memory. So I want you to think of these kind of as like snapshots in time. This is as if we are taking a photo of something. You get that one moment in time, but you don't get the stuff that is before or after the photo. That is sensory memory. Snapshot, quick, 1 second, 1 moment of information. Once we pay attention to sensory information, then it is in our short-term memory. And our short-term memory, I like to think of as like our conscious awareness, what we are paying attention to at the moment. This is very limited. We only have our short-term memory for about 30 seconds, and it has a pretty limited capacity of amount of information that you can keep. You can keep about 7 items in your memory, short-term memory at once with plus or minus 2. So anywhere from between like 5 and 9 items. And by items, I really mean like a piece of information. So it can be like numbers or a list of items. It can be words. Whatever it is, you can keep about 7 of those things in your short-term memory at once. People get really good at short-term memory if they learn some of the tactics that we use to make our memory better, like chunking. So for example, if we wanted to remember this giant list of letters, it would be really hard for us to remember each individual letter. However, if we break it up or we chunk it into smaller pieces, then we can remember them a lot easier because we have 7 of those TV channels rather than individual letters. So if we want to move our information from our short-term memory to our long-term memory, that information has to be rehearsed. We have to repeat the information over and over again. And that can be done in a number of different ways. If you are walking from one room to another, that might just be you literally repeating the a phone number over and over again as you walk to another room. It could be, however, you saying it out loud, writing it down on your paper, thinking about it. So if you don't rehearse the information, that information will be lost. However, if you do rehearse it in some way or another, that information gets transferred to long-term memory for storage. Long-term memory is our memory where pretty much all things are stored in our brain. There isn't really one location that long-term memory is stored. Long-term memory is stored all throughout different areas of the brain because our memories are taken apart and stored in multiple different locations. So long-term memory has almost an unlimited capacity. We as psychologists believe that it's relatively permanent, and we really haven't seen any sort of capacity to the amount of information that can be stored in long-term memory. That does not mean, however, that long-term memory is perfect. We know that memory can be distorted, and we know that memory can be changed. And so we just know that it's there. Whether or not it's accurate is the next question. There are some limitations to the original multi-store model of memory, and that is that sometimes information that we take in skips through sensory memory and short-term memory and goes immediately into long-term memory, meaning that some information that we don't necessarily pay attention to gets encoded, and we don't even realize that it gets encoded. And so we don't really have an explanation for that, of why that would potentially happen, because Atkinson and Schifrin say that memory happens in this linear process from sensory, short-term to long-term. The other problem with this model is that sensory memory doesn't take every single piece of information in at once. It pays attention to only the specific things that we deem necessary as a conscious being. And so this process, known as selective attention, isn't really explained by the sensory model of memory. The third problem with this model is that short-term memory is a lot more complex than just your conscious awareness, right? We know that we can do multiple things at once in our short term, and we can remember certain things while also doing other things. And that's why we need a little bit more of an expansive model of short-term memory. And that model came from Baddeley and Hitch, which is the working memory model. This model 100% agrees with the process that there's a sensory memory and there is a long-term memory. However, they just take that short-term memory and they add a little bit of spice to it. So instead of calling it short-term memory, we call it working memory. And working memory is just a newer understanding of what's happening during short-term memory. It adds in this conscious awareness, this active processing. It adds in this idea that not only is our short-term memory putting information into our long-term memory, but it's also bringing information back to our consciousness. Baddeley and Hitch add that working memory has multiple different components. The first component of short-term memory is the central executive. Think of this as kind of the boss and the head of a company, right? The CEO of the company is going to make a lot of the decisions. And so the central executive is going to control where our attention lies. What are we going to pay attention to? What are we going to do? And this is at an automatic level. So the central executive is going to pay attention to things like writing that you don't necessarily have to consciously think about, but the central executive allows those procedural memories to happen. The other part of the central executive is the supervisory attention level, which is really taking in the unique situation that you're in and making sure that you know what you need to be doing. So using past experiences to make sense of this new situation. The next part of our working memory are the slave systems. And I really don't like this name, but that's the name that they gave it. And so we have to think about slave systems as kind of like the worker bees. These are what the central executive has control over. There's 3 different slave systems, and each one of them does a little bit different of a thing, and it allows our conscious awareness to work. The first is the episodic buffer. Think about episodic, like episodes of a TV show, that you are pulling out information of what actually happened. This is your ability to bring to your conscious awareness a memory that happened, like what happened at the homecoming dance or what happened at the last football game. It's also what's going to be processing and putting that information of what's happening around you into your long-term memory. The next slave system is the phonological loop, and this is your inner voice. And our phonological loop is your ability to hear yourself talk within your mind. So you can also hear like songs or maybe someone talking. So this is your phonological loop. Now, I want to be clear. Not everyone has this. Not everyone has the ability to hear voices in their head, but most people do. Finally, the last is the visuospatial sketchpad, and this is our inner eye. This is your ability to see things in your mind. So if I ask you to picture an apple, it's your ability to actually picture an apple in your brain, whatever that apple looks like. It could be a realistic apple, it could be a cartoon apple, like your ability to picture something in your mind when we tell you to picture it. So all 3 of these systems work together. They explain our ability to multitask. So if you're being read a story, you're taking notes on that story, you're also picturing what's happening. All of those things are working at the same time. And those are our slave systems and our central executive working together to allow us to multitask on something. This is a visual representation of what that working memory model looks like. So our central executive, visuospatial sketchpad, episodic buffer, and phonological loop are all part of our working memory. And our working memory is kind of that in between of our sensory memory and our long-term memory. And it's the things that are happening in our conscious awareness. So the things we are doing in the moment. And you'll notice that these arrows kind of go back and forth between all of the different parts and long-term memory, because we know that not only does our working memory control what's in our conscious awareness right now and put that back into long-term memory, so encode new things, but our working memory also allows us to retrieve information from our long-term memory. Okay, so for IB, one of the things that you're going to have to do is not only know the content, so know the different models of memory, so multi-store with Atkinson and Shiffrin, and the working memory model, but you're also going to have to know some research to back those up. And really what that means is you're going to have to say, yep, that theory is correct. And here's some research to show that that theory is correct. So the next part of this video is going to give you some of the research that's going to help support one of the models of memory. And the model of memory that I have chosen for us, to make it very simple, is the multi-store model. So this is when we're looking at sensory, short-term, and long-term memory. And we are going to look at the 3 different research studies that you can use as evidence to back up the fact that this model of memory is correct. So the first one that we're going to talk about is the case of HM. This case study is super important. You will use this case study multiple times on the IB test. We talked about it already in our bio unit, and now we're going to talk about it again in cognitive, and it comes up later on as well. So the case of HM is super important. This research study was done by Milner in 1966. A little bit of background on HM. HM was from Connecticut, and he was born in 1926. When he was 7, he was crossing the street and he was hit by a cyclist. And this led to a very serious head injury. So much so that it led to epileptic attacks when he was about 10 years old. They started, and those are seizures. So he started having seizures at around the age of 10. By the age of 27, he could not live a normal life because of the amount of seizures that he was having. He was having dozens of seizures a day. And this was just leading to him not being able to even hold a job, take care of himself, because he was falling to the ground and potentially harming himself each time that he had a seizure. So his neurosurgeon, William Scoville at the time, decided to do a new type of surgery, and that was a lesioning of part of his brain. So he had tissue removed from the temporal lobe on both sides of his brain. And the tissue that was removed included his hippocampus. We know from our bio unit that the hippocampus is used in order to take information from short-term memory and transfer it to long-term memory. And this is the study that tells us that. So this was a longitudinal case study, which means that the study was done over the course of many years. And it's also method triangulation because there are multiple different tests that were used in order to gather information about HM. A reminder, a case study is when we're looking at one particular individual in depth over the course of time. And this is exactly what happened with HM. They did IQ testing on him, they observed his behavior, they did interviews with him and his family members, they did cognitive tests like memory recall and learning tasks, and they also did brain imaging as well. So over the course of this study, they found that really HM's personality did not change very much after the surgery. However, the primary problem that Milner saw throughout this time was the anterograde amnesia. And this is the idea that HM was unable to create new memories. He could carry on a conversation within the moment, but he was not able to remember anyone after he had that conversation. So if it was a new person that he met, he could not remember that person if they left the room or if they came back the next day. So what does this mean? Those are those implications. It means that the short-term memory and the long-term memory are stored in separate parts of the brain. Because HM could remember things from his childhood, we know that that long-term memory that happened before is in a different part than our actual conscious awareness, those things that are happening in the moment. It also must mean that there are 2 separate memory stores. Our short-term memory and our long-term memory are separate from each other. Because HM was not able to create the new memories, nothing was being transferred to that long-term memory. And so we know that that short-term memory must happen somewhere else. It must be separate from long-term memory. It also tells us that the hippocampus probably has something to do with moving information from the part of our brain that controls short-term memory to our long-term memory storage. So some evaluation of this research study. Because it's a longitudinal study, we know the changes that are happening in HM over the course of a long period of time. Also, it's a great thing when we're using method triangulation because it confirms our findings in multiple different ways. There is some evidence to confirm these findings. So there are other case studies of people who damaged their hippocampus that confirm this information. But again, because these are case studies, it's really hard for us to generalize to a larger population. The next study we're going to look at is Glanzer and Cunitz. And Glanzer and Cunitz actually have two different studies we're going to look at. And both of these studies are dealing with the serial positioning effect. Serial positioning effect tells us that we will remember the words at the beginning of a list and the words at the end of a list. We tend to forget the ones that are in the middle. And the serial positioning effect is made up of two different ideas, the primacy effect and the recency effect. And each of Glanzer and Cunitz studies focus on one of these effects. So the first one we're going to look at is the primacy effect. And this is the idea that we remember the items at the beginning of a list because we have had time to rehearse those items. Therefore, they've been sent to our long-term memory. So the aim of Glanzer and Cunitz's first study was to see if the amount of time between words on a list would increase the number of words recalled at the start of a list. Basically, if there's a longer interval of time, we have more time for rehearsal, therefore we'll remember more of them. Okay, now going into the procedure. Part of our procedure that we need to know are the participants and the design of the study. So there were 240 enlisted Army men, and this was an independent samples design, which means that each participant in the study was only put into one condition. And you will see those conditions on the next slide. So the 240 enlisted Army men were divided into groups of 40. And each of those groups of 40 were randomly assigned, or each man was randomly assigned to one group of 40. And those groups were the following. Each word was read once at a 3-second rate, each word read twice at a 3-second rate, and then so on and so forth for 6 seconds and 9 seconds. During the procedure, each group listened to recordings of 8 20-word lists. These were the same lists, except for they varied the time that they read between each word and then the amount of times they repeated the word. After each list was read, participants were given 2 minutes for free recall. Free recall is the idea of just taking a piece of paper and writing as many of those words down that you can remember. It doesn't matter what order you remember them in, just write down as many as you can. So what Glanzer and Cunitz found when they looked at all of the words that the participants remembered is that the amount of time that you increase between each word, so 3 to 6 to 9, did lead to an increase of recall in all of the words, except for those at the end of the list. So words at the beginning and in the middle of the list, people remembered more when there was more time between each word. They also found that the repetition, so saying the word twice, only helped people remember at that 3-second interval. It did not help them at the 6 or 9-second intervals. So what does this mean? Well, it means that the primacy effect is happening because of rehearsal. Because we increase the amount of time between each word that is read, that allows the person to say it over and over. And the rehearsal allows those words to be put into long-term memory. Therefore, there's an overall greater recall of those words at the beginning and the middle of the list. The next study that Glanzer and Cunitz did was to study the recency effect, so the opposite of the primacy effect, recalling words at the end of a list. They believed that the words are remembered at the end of the list because those words were still in short-term memory and they hadn't been displaced by new information yet. So the study that they developed was to see if increasing the time between hearing words in a list and recall would influence the number of words recalled from the end of a list. The participants that they used for this were 46 enlisted Army men, a very small number for a sample size, and they used repeated measures for this particular study, which means that they put each of the men into multiple conditions. For this procedure, each participant was shown 15 15-word lists, and these were common one-syllable words. They were shown these lists on a screen, and they were shown each word for about 1 second, and then there were 2 seconds in between each word. So it would flash a word on the screen for a second, then it would go black, then another word for a second, then black for 2 seconds, then another word, and so on and so forth. While the words were flashing on the screen, the experimenter also read the word. So the participant was reading it on the screen and hearing it. After the list, participants were then asked to free recall the words, and they were put into one of 3 conditions. The first was immediately recalling. So the minute that the list was done, they started writing down the words that they could remember. The next condition was waiting 10 seconds between hearing the list and writing them down, and also doing a distraction task in between when they heard the list and when they wrote down. The distraction task was counting. And then finally, the third condition was a 30-second delay. So 30 seconds in between the end of the list and when they could write down the words they remembered. And again, they did another distraction task where they were counting. Each participant was tested individually, and the list of words was randomized throughout the study to make sure that there weren't some words that were more memorable than others. What they found was that the immediate recall, the participants remembered the words at the end of the list, that recency effect. Because the words were still in the short-term memory, the words were remembered more frequently. Within the 10-second delay, Glanzer and Cunitz saw a significant reduction in the words remembered at the end of the list. And then finally, with that 30-second delay, there was no trace of any of the list remembered. There was no trace of any of the words from the end of the list remembered. What does this mean? Well, it means that the recency effect is because the words of the list are still in our short-term memory. If there's a long enough delay between when the list is read and when you are asked to recall the list, you're not going to be able to remember the words from the end of the list because they're no longer in your short-term memory. This gives us proof that short-term memory has a limit, that there is only about 30 seconds for us to recall words, and that our short-term memory replaces the information in it pretty quickly. And that was shown through the distraction task. Because people aren't allowed to rehearse those words at the end of the list, they weren't put into our long-term memory.